Hey guys, welcome back to my channel. The topic for today is going to be training on the cloud with Google's Cloud ML engine. So why use Cloud ML engine? So first of all, what is it? It's a bunch of computers on Google's infrastructure which are optimized for training ML models. So it gives you instant access to a bunch of supercomputers which are clustered together on Google's infrastructure. What this is going to enable you to do is to train beyond your local machine. So you can train multiple models at once, or you can train a model which requires resources which are too great for your local machine. Another great thing that ML Engine provides is hyperparameter optimization. What that is if you don't know what batch size to use or how many neurons to use per layer, or how many layers to use in your model, you might have all these scalar values which you don't know what value to set to them. What this is going to enable you to do is use evolutionary algorithms to find the exact proper scalar value to maximize your or to minimize your loss. The first thing we want to do is create a Google Cloud project and enable the proper APIs. So I'm going to open that up and show you the process of doing that. So here I'm in the Cloud console. This is my dashboard, and you can see my current project is called CoinOp, which is my project I'm working on, and you can click on it to choose which project you want to work on, and you can add new projects like this. In the hamburger menu, you'll find ML Engine, Storage, Billing, and the API Manager. I've pinned these. You might not see them here, but you might be able to scroll down and see them down here below. So first of all, we're going to go to the API Manager and make sure we have enabled the proper APIs. The APIs you'll want to enable are Compute Engine, Billing, Storage, and ML Engine itself. So when those four are enabled, your project will be ready to go. After you do that, you'll want to download the command line tools for Google Cloud. I've linked this quick start guide for Mac OS. There's also one for Windows and Linux here on the sidebar. Basically, once you download GCloud, which is the command line function, you're going to initialize it, choose your project, and choose what compute zone you're in. So whether you're in Asia or you're in the US on the East Coast or West Coast, there's going to be a one-time configuration. And in the future, if you want to change any of those values you've set, that's going to be in your GCloud config. So you're able to set new parameters on that config later if you want to change it. Once you've done that, the first task to getting your project ready for training in the cloud is to upload your training and testing data to Google's Cloud Storage. So Google Cloud Storage has this useful utility called GSUtil, and what you're going to do is you're going to copy your local file, your local data, which I have pickled just for easy access, and you're going to copy it to a Google Cloud Storage bucket. So I take my local data and I copy it to a cloud URL, which is this data in Google Cloud Storage. Once I do that, I'll be able to go to my cloud platform and I'll be able to go to my storage. And in my data, I'll see input. And these are the various pickles that I've uploaded for my own project. Now you need to prepare your actual code for cloud training. This requires having a directory structure set up in a certain way such that Cloud ML recognizes it. So what I'm going to do is I'm going to open up my project and I'm going to show you how it looks. So first of all, you'll want to move all your training code into its own directory. So I created a directory called trainer, and I've moved various training files into that one directory. Inside that directory, you'll see a YAML file, which is for configuration. Opening that up, it's very simple. This tells Cloud ML what type of service you want. So there's different scales of services you can request. Basic GPU is one of the simplest ones, but it's one that has been sufficient for me when I'm just training and testing my models. External to the trainer directory is going to be a setup.py file. That needs to be at the top level of your project. Inside of there, this is crucial for if you're training using Keras. You're going to declare this setup function. It's going to have various parameters, but one of them is install requires. Here you need to tell Google's Cloud ML that your project requires Keras because it doesn't install Keras by default. Another one is h5py. I use this for loading and saving my models after they're trained. So if you don't put this in here, Cloud ML will complain saying it cannot find Keras. So that's pretty crucial. And then this file, which is inside my trainer directory, I call it cloudtrainer.py. This one's going to be responsible for reading the command line arguments and actually loading up your model. So it's going to create the model. It's going to load up your data. This is actually going to fit your models. This is the actual training part. And then it's going to save it back to the cloud. So after your model has been trained, you'll want to save it to a Google Cloud Storage location. So this function, you can pause and look at this function more closely, but what it does is it opens some file I/O using Tensorflow's I/O package, and actually is going to write my model to a Google Cloud Storage location. One thing you'll want to do is change your Tensorboard config to point to a Google Cloud Storage location. This will allow you to view Tensorboard while you're training on the cloud and after the training is complete. So in my particular use case, I have my Tensorboard callback defined here, and this log directory is going to be a Google Cloud Storage path. So it's going to start with gs:// and then a path to local storage. So now that your code is ready and your directory structure is proper, we're going to want to issue the command to Google's Cloud ML to actually begin the training. So here on this slide, you'll see I've named a couple of constants, which I think you don't need to change often. Every time you issue a training command, you'll probably want to update the job name with a new job, some type of key which helps you recognize which model you're training. And this training file here was used by my Cloud Trainer file to determine where my training data is on Google Cloud Storage. So after you define these constants, you're going to issue this command: GCloud ML engine jobs submit training. And then you're passing in the constants you've defined, like job name, which is the key. Job directory is where you want to save your model when you're done training. It's also where you're going to save your logs for Tensorboard. The runtime as of July 18th is 1.2. The module is Cloud Trainer, so that's the name of that main training file which I showed previously. The package path is going to be relative to your project where your training files are. So I nested my directory into a trainer folder, and that's where all my files are. So that's the package path. Region is where you want where you are, or closest to where you are. Cloud config is the path to the YAML file inside your trainer, which defines basic GPU, the scale tier for your ML engine. You'll notice here everything below the double dash, these are ones I use personally for my own project. Everything above it, ML engine requires. So these are all required in ML engine, and everything below this double dash is just what I personally prefer using for my own project. So let me issue this command. Here are my constants, and then I'm running the command there. So when I run it, I'm just running one epoch right now. That's going to be defined by your trainer. Once I submit it, it's going to say submitted successfully, your job is active, and you can find the logs here. So rather than doing this through command line, we can now go to ML Engine from the Cloud Console and view the job which is now running. So here in ML Engine, we can go to Jobs. And you'll see this test job, which I just issued, is now going to be running. It's going to take some time to boot up and find and to provision the machine. And once it's provisioned, it's going to start the actual training process. Something cool you can do is view Tensorboard right here through the Cloud console. So up here, there's a Cloud shell you can open. So once the Cloud shell is opened, I can then run Tensorboard directly inside of it. And what I'll do is I'll put my job name in here, which was called test job. And the Tensorboard callback was set up to do test job /logs. So if I run that, it's going to open up Tensorboard on a port local to the provision device. So it says starting Tensorboard on port 8080, and right here I can say preview. So I accidentally put a space when running the Tensorboard command, but I actually found out something cool, which is that if you run Tensorboard on a whole folder of different logs, it will actually show all the graphs on top of each other, which can be useful for comparing models. So you'll see here, I have 3 different jobs running and for a certain amount of epochs, and I can actually gauge which one had the best accuracy over time, so it's actually a useful tool. We can go back to the Cloud console now to view our model which has finished training. We want to download it so that we can perform inference on it. So we'll go to our storage. We'll have jobs here, which is where we're storing every model. Let's take another job I ran, which was this one. Clicking on it, I'll see I have my model.h5. So I've saved the model, which has already been fit, and now I can just click on it, save it, and then run inference on it offline. Something useful I also do is, after every epoch, I have a callback which saves the progress of the model. This is going to be useful to see the progression of training over time, or perhaps the very last model, which was in the last epoch, wasn't the best one, and maybe halfway through the training you actually created the best model and you didn't realize it. So saving the progress of the model is also helpful here. So just some pro tips. When you're running on Google Cloud ML, you're going to want to make sure you're making full use of the machine which is provisioned to you. So for example, if you have a very low batch size, you're not going to have great gains from using a good GPU. So by increasing the batch size, you're going to get a lot better performance out of that GPU. And what that's going to mean is training will take a lot shorter and you'll be charged less for using ML. I've found that using Cloud ML costs about 25 cents to $1 per training session, which isn't that much because you're not training an insane amount of times per day. You may be spending $2 a day trying to train your model, and you're training in parallel, so you're much more efficient using Cloud ML. So that's about it for today's talk. I wanted to say I'm going to post the links of these slides in the description, as well as some other useful links about Cloud ML. So thanks so much for watching today, and if you like it, click the like button or subscribe. Leave a comment saying what you liked or didn't like and what you'd like to see in the future. Thanks so much for watching.